Hello, in this video we will see how do we evaluate the Fourier transform for the function fx, which is defined as x when the limits of x varies from 0 to 1 and 1 minus x when it varies from 1 to 2. For rest of the portion it's 0. Okay, so we need to find the Fourier transform. So let's first see what is the formula for the Fourier transform. This is the formula of the Fourier transform for any function f of t. Okay, so what we need to do here is our function is in terms of x, so we replace it in terms of t. So what we will be doing, replace x by t in all the places. So what our function becomes, it becomes f of t equals t when value of t varies from 0 to 1, and it is 1 minus t when it varies from 1 to 2. Okay, now using this formula, what we have to do is we have to substitute the value of t, f of t, between these intervals. Now what we have here is this Fourier transform is defined over the entire interval minus infinity to infinity. Okay, we have the value of our function from the interval 0 to 1 and 1 to 2. So within this interval it is t, and within this interval it is 1 minus t, and for rest of the interval it will be considered to be 0. So let's write down these things. Our Fourier transform become fs is equal 1 over square root of 2 pi. Now we can see that in these two intervals it will be 0. The only non-zero value will be in the interval 0 to 1 and 1 to 2. So we will have two non-zero integral. One is from 0 to 1. F of t, in place of f of t from 0 to 1 it is t, and then e power minus iota st dt, plus in the interval 1 to 2 the function f of t takes the value 1 minus t, e power minus iota st dt. Correct? Now both becomes a question of definite integral and we have to integrate it. So let's say this is 1 and this is the second integral. So if we work with the first integral, it is 0 to 1 t e power minus iota st dt. You know that it is a two terms in multiplication under the integral sign. So and both are the linear both functions we have the rule, so it means it should be integration by parts. So if you don't remember how to distinguish between integration by parts and substitution, you can go for the video based on that topic. Okay, I already prepared for that. So here we will use the shortcut method because one of the function is algebraic function which after certain derivative becomes 0. So we can pick this formula, like we select one of the function which is algebraic to be derivative and the other function to do the integration. Both are with respect to variable t. Now let's do the process. In derivative of t is 1, derivative of 1 is 0. So we stop here. After 2 times we differentiated 2 times to reach 0. Now we integrate this term function 2 times. So integral will be e power minus iota st. As we are integrating with t, the coefficient of t is minus iota s. So it will come as in the denominator. Integrating again, it is e power minus iota st, and again minus iota s will come, so it will become power 2. Now we need to collect this term to write the value of integral. So we start with the positive sign. As we move to the next term, we change the sign. So negative and then positive again. And we will multiply the term in the cross. Okay. It's up to you. You can either use this method or you can use your regular udv method, which is uv minus integral v du. Both will give you the same result. Now writing down the value for the integral I, what it will be. Its product of these two terms, the term will be t e power minus iota st over minus iota s. And product of these two terms, here minus, here the sign is positive, so it will be negative e power minus iota st over minus iota s power 2. Limits for t is from 0 to 1. So now we have to substitute the limit for t. T here, here and here at 3 places. First we replace it by t equal to 1 and then by 0. Okay, so when we replace it by 1, we get 1 time e power minus iota s, because the value of t is 1, minus iota s, minus here e power minus iota s minus iota s to the power 2. Now when we substitute 0, 0 multiply anything, the first term will become 0, and e power 0 over minus iota s to the power 2. Let's simplify it further. So we'll get e power minus iota s over minus iota s minus e power minus iota s minus iota s to the power 2, and this minus minus become plus. Any number power 0 is 1 over minus iota s to the power 2. So this is the value of the first term. Let's go to the second term and integrate it in the same way. So again we will use one function, as this function is there, which after certain number of times differentiation becomes 0. So we select it for the differentiating and the other term for integrating. Again using the integration by parts. Again for this one, can use this value as well. So derivative of 1 minus t is minus 1 and its derivative is 0. This become integration of this term. Similar to this previous term, it will be same, integrating 2 times. Okay. And then take the sign, it is plus, minus, plus, multiply and cross. Here be careful that it's 1 minus t, so put it inside the bracket, because this entire term getting multiplied with e power minus iota st over minus iota s. Recollecting the values now. So we get the value of this integral as 1 minus t times e power minus iota st over minus iota s, minus minus become plus, e power minus iota st over minus iota s to the power 2. And the limits for t is from 1 to 2. So again we have to replace t first by 2 in these 3 places and then by 1, which will give you 1 minus 2 e power minus 2 iota s over minus iota s plus e power minus iota s times 2 over minus iota s power 2. Changing it to 1, we'll get 1 minus 1 e power minus iota s minus iota s plus e power minus iota s minus iota s to the power 2. So 1 minus 1, this term gives you 0 and this gives you minus 1. So let's write it. It gives you minus e power minus 2 iota s over minus iota s plus e power minus 2 iota s minus iota s to the power 2. This term becomes 0 and this term is negative e power minus iota s minus iota s to the power 2. So this is the value of second term. Now writing the final value of the Fourier transform, it will be addition of the second value and this first value. So let's write it. So we have fs equal 1 over square root of 2 pi. For first one it is e power minus iota minus iota s e power minus iota s. Be careful. Carefully note down all the terms for both the integral. So we have 3 terms for the first part and 3 terms for the second part. Minus iota s e power is 2 iota s minus iota s power 2 and minus e power minus iota s minus iota s to the power 2. So this is the solution. You can further simplify it by combining the similar terms. Like you can see in these two terms, you can take the denominator as a common factor. This term and this term is same, so it will become 2 times, and then you can take denominator common from here. Okay, you can combine the terms in this way. If you want, you can further do the simplification by considering iota square to be minus 1 to remove this sign. It depends, like if it is asked prove that to a certain specific term, you can do that, otherwise you may stop here.